Class 12th, I am telling you about the force between two parallel current carrying conductors. Let this is the conductor. It carries current I1. This is another conductor carrying current I2. That this is the conductor P1, this is the conductor P2, and the distance between them is R. So we can say that the conductor P2 is placed in the magnetic field due to the conductor P1, and conductor P1 is placed in the magnetic field due to the conductor P2, because both the conductors will produce their own magnetic field. Both the conductors carrying current produce their own magnetic field. The magnetic field due to conductor P1, B1 equal to mu naught upon 4 pi into 2 I1 upon R. This is now its distance R. Then this will be vertically inward to this plane of this board. Vertically inward, like this. We are having by right hand rule, my fingers are going inside this board, so the magnetic field will be inward of this blackboard. Now force on charge, the force on conductor P2. This is now your BF equal to B1 L into I2. L is the length of this conductor. L the length of this conductor. So B1 is the magnetic field to this one, L the length of this conductor, then I2 the current in this conductor P2. So now what we have? That this F equal to this is equal to mu naught upon 4 pi into 2 I1 upon R into L into I2, or this is equal to mu naught upon 4 pi into 2 I1 into I2 upon R into L. This is now equal to F. Now so much force will act on this conductor. So the force per unit length, this is so much Newton. Force per unit length, this F equal to mu naught upon 4 pi into 2 I1 into I2 upon R. So much Newton per meter. This is not so much. Now when this field is vertically inward and this is now current, then what is the direction of the force? Now you apply the left hand rule. The current, this is the magnetic field, this is the current, this is now force. The magnetic field inside to this one, then I can have my hand like this one. The forefinger is vertically inward. Now this middle finger in the direction of the current. Then this force is acting towards P1. So this force will act like this, F. So this force will be towards P2. The force F is towards P1. Now similarly, if you find the field, if you find the force on this conductor P1 due to the conductor P2, we will have the same expression, but the direction of the force will be just opposite to what we have the direction here. Similarly, the force per unit length on the conductor P1 due to conductor P2. Now this F equal to mu naught upon 4 pi into 2 I1 into I2 upon R. This is so much Newton per meter. This is so much. Now it will be towards P1. Towards P1. Towards P2. So this force will be like this. This is now force F. So what is that? When the current in the conductors is in the same direction, then both the conductors will attract each other. Thus the force between the current carrying conductors in the same direction, it is the attractive force. Thus, when conductors carry currents in same direction, they attract each other. So if the current is in the opposite direction, then they will repel. This is now suppose the current, this is now your I1 and this is now conductor second one, this is now carrying current like this I2. This is now your P1, this is now your P2. Then this force will be in this way and this force will be in this way. So this is now force of attraction. when currents in parallel conductors are opposite, the force between them is repulsive, like this. So from this one you can give a definition, that is called the international definition of 1 ampere. International definition of 1 ampere. Now we are having using this relation F equal to mu naught upon 4 pi into 2 I1 into I2 upon R. So what we have, that if I1 equal to I2 equal to 1 ampere, R equal to 1 meter, then F equal to, this is now your 2 into 10 raised to the power minus 7 Newton per meter. So we define that 1 ampere current, 1 ampere is the current which when passed between the two parallel conductors placed at a distance of 1 meter in the air or vacuum, then the force between the force on each conductor is 2 into 10 raised to the power minus 7 Newton per meter. One ampere is the current which produces a force of 2 into 10 raised to the power minus 7 Newton per meter. Now 1 ampere is the current which when passed through two parallel conductors passed into parallel conductors placed at 1 meter apart from each other, which when passed in two parallel conductors placed at 1 meter apart from each other, air or vacuum. One ampere is the current which, when passed in two parallel conductors placed at 1 meter apart from each other in air or vacuum, produce a produces a force of 2 into 10 raised to the power minus 7 Newton per meter on each conductor, on the conductor. This is the international definition of the 1 ampere. And now we have the particular cases. Particular cases. Number 1. Suppose these are the some protons. This is a positive particle, and this is moving like this. This is also a positive particle. This is moving like this. Then they will produce the current. This is positive particle. This is positive particle. Then this current will be in the same direction. So they will produce the same current. This is now I and this is also now I. Then they will attract to each other. Attract to each other. If suppose we are having this an electron moving in this direction, and this is suppose a positive charge particle moving in this direction, then electron is moving in this direction, so current will be just opposite to this one. So this will be the direction of current. This is now your direction of current. Here the direction of current like this one, and this is the direction of current here. This is I. So what we have, the two currents are the opposite. So they will repel to each other. They will repel to each other. F like this. If suppose we are having that two, suppose this is a electron, this is moving in this direction, and suppose we are having a positive charge particle, this is moving in the opposite direction of this one, then it will have the current in this direction, I, and this will have the current in this direction, I. So now both the currents are in the same direction. In this way there will be force of attraction. So when we are having a charge particle or a beam of charge particle which is moving in a certain direction, then that will produce the current. Now we have to find whether the given beam is the negative charge particle or a positive charge particle. Then you find that what will be the direction of current. If the direction of currents are in the same direction because of both the beams, then they will attract to each other. And if the currents because of both the beams are in opposite direction, then they will repel to each other. So this is given sometimes in the question paper, that if suppose the electron is moving from left to right and a positive charge particle like the proton is moving from right to left, then what will be the nature of the force between them? Either this is attractive or this is repulsive or none of them. Then you can say that if both the oppositely charged particles are moving in the opposite direction, then the current because of them will be in the same direction. So they will attract to each other. If the same kind of particles are moving in the same direction, then current also will be in the opposite direction because of them. So again, the current is in the same direction, then they will attract to each other. But if we are having the particle one to be now positive and second to be now negative and moving in the same direction like this one, then they will repel to each other. This is a repulsion, this is attraction, this is again a attraction, because this is moving in the opposite direction. So this is what the question that is sometimes asked in the board exam also, and also in some competitive exams. So these are the some special cases of the moving charge particle when they will attract or they will repel to each other. So thank you very much.